All right. Well, good evening, everyone. How is everyone tonight? Fantastic. I love to hear that. Welcome to the Dyer Observatory. Anybody here for the first time? All right. Well, welcome to everyone. So glad you all could join us this evening. We're going to have a fun time. Doesn't look like we're going to get to do any viewing tonight, but you never know. Keep your fingers crossed. Those clouds might push on out of here and we can get to actually see something. But before we get started this evening, I just have a couple of announcements. Dyer Observatory is not doing our regular summer camps this summer. We're actually teaming up with Peabody. We're piloting a new summer camp program with them. But we are doing some new summer programming down here in June and July. And we're just about to release details on our website about how to sign up for that for rising 5th, 6th, 7th, and 8th graders. So next few days, keep an eye on our website, and you're going to see that info pop up. So we're really excited about trying out this new programming, and I think it's going to be a big hit. Let's see. We have additional events coming up this year, like telescope nights, other Meet the Astronomer nights. We've got concerts coming up with the Bluebird Cafe, Opera on the Mountain. That's always a big hit as well. So keep checking our website, especially our ticketing website, Eventbrite. We're going to continue adding things to that. And if you've gone to our ticketing site, you'll see a little follow button on there. Click on that. It'll ask you for your email address, and when you sign up for that, you'll get a notification whenever we add something new to our lineup. So we still got a lot of stuff going on this year, so be sure to follow us on that. Let's see what else we got here. Sorry, I lost my notes here. Okay. We also will advertise a lot of our events in our newsletters, so if you haven't signed up for that, you can go online and do that. And you can also do the sign-up sheet that is in our front lobby as well, and we'll get you added to that newsletter. It's once a month, and lots of great info in that. So without further ado, let's talk about the program for tonight. So it's going to run about 45, maybe up to 60 minutes long, we'll see. We're going to then open up the floor for questions afterwards. We are also live streaming to YouTube this evening, so we got some folks at home watching. So for folks at home, if you get a question, just put it in the chat, and we're going to try to get to as many of those as we can at the end of the talk. And then after the program, you're welcome to go up and check out the Seyfert telescope, check out our exhibits, ask us questions, and we'll still have a great time, even though we might not get to see anything. But fingers crossed, we're going to get to see something. Let's see. Our speaker tonight, William Lamb, he's returning. I think this is the third time. Okay, so third time. He is a fifth-year PhD astrophysics candidate at Vanderbilt University, where he works with the NANOGrav experiment that studies gravitational waves with a galaxy-sized detector. You can probably ask him about that afterwards, to measure black hole astrophysics and cosmology. And tonight he's going to be telling us a little bit about Celtic Constellations, and I can't think of anybody better to explain that to us than someone who's originally from Wales. So without further ado, let me turn it over to soon-to-be Dr. William Lamb. So let's give him a big round of applause.
Thanks, Billy. Everyone hear me okay? Am I coming through? Awesome. All right, yes, hi, my name's William Lamb. I'm a fifth-year astrophysics PhD candidate at Vandy. I'll be graduating next year, so I've still got a year to go, still got a lot of work to do. But yeah, I'm originally from a country called Wales, or as I call it, Cymru, which is in the UK. And my first language is Cymraeg, or Welsh. So I wanted to talk a little bit about constellations and how my home connects to that. So thanks to Dyer for giving me this opportunity to give this talk. So a little about me first. I worked for the NANOGrav experiment. 2 years ago, we gave a presentation here when we had our big results announcement. We're still working on improving detector and doing some more data analysis and trying to improve our measurements. So that's pretty much what my PhD is about. If anyone doesn't know where Wales is, this is the most common thing I hear. I've been in here for 5 years, not even my partner even knew that when we first dated. This is her on the right here. Her name's Chelsea, and she's loved my life. But yeah, Wales is over here in the UK. It's its own country, along with Ireland, Northern Ireland, Scotland, and England. This is a mountain back at home, which is a very mountainous area. It's very beautiful. and it's a dark sky area as well, and that's why I got into astronomy. I'm also swimmer, cyclist, runner, trying to improve my fitness to become a triathlete, and also a swing dancer, and that's how we met. This is our little baby here, Wiggle Worm, sweet little orange boy, and this is a little label to show that I speak Cymraeg. So a lot of this talk is based on 2 blogs that I wrote for a website called Astrobytes. Astrobytes has been a big part of my PhD life. We write little reviews of the latest astrophysics and space research in just like a little small condensed way that is easy for people to read. And I wrote 2 pieces on this. Started off with a book review of this book. I'll highlight this later. And then just a little further explanation on Celtic Constellations. And I thought I'd turn this into a paper. Oh, actually, that's the book. It's right there. I forgot. It was there. It was written by the dark sky officer for my local national park. Her name's Danny Robertson. The national park is a registered dark sky area, so there are specific rules on what kind of lighting you can have and to make sure that it's got pristine dark skies for people to do astronomy and astrophotography. And this is the name of the national park, Eryri. Okay, so let's start off with constellations. I'm going to be asking you all some questions throughout. Does anyone recognize what this constellation is? Yeah, Orion, that's it. So Orion is a hunter. That's pretty much all I remember from that story. But yeah, pretty much most of the constellations in the Northern Hemisphere that are male are going to be like hunters or heroes and such. So first question is, what is a constellation? So I just took this straight from Wikipedia. Constellation is actually not just a grouping of stars or a pattern, but it's actually an area on the sphere. When you look out into the night sky, it's a sphere that groups some visible stars together, and it forms this perceived image that we have, such as an animal or mythological object or some hero in mythology or some inanimate object. And the International Astronomical Union recognizes 88 constellations as official constellations that we use in astronomy. Some of you all will recognize the group, the IAU. I'll talk to them a little bit more about them later, but they're the group of people who demoted Pluto to be a dwarf planet. So a constellation is slightly different to what we usually think is a constellation. It was actually an asterism. So it's a pattern or a group of stars that create some sort of shape in the sky that we perceive to be some sort of object. So one of my favorite down here is Sagittarius, or a part of Sagittarius, which looks like a teapot. Let me get my little laser pen out. Here we go. So yeah, you can see a little bit of little teapot. I love tea. I'm British. And you know the tea is ready when the teapot is steaming. So here you got the Milky Way coming out here looking like steam from the spout. So I want to talk about what constellations are actually like in space. Like, are they just these stars that are grouped together, or are they more spread apart? Where are they? How far away are they? So before we do that, we need to calibrate ourselves to all the different distances that we have in space. And distances are really, really big in space. Space is just really, really big. So we usually measure things or distances in terms of light years. So a light year is the distance the distance that light travels within a year. And that is about 5,900,000,000,000,000,000 miles. Any engineers or scientists in the room will recognize this, 10 to the 12 miles, it's big. Anyone who uses more reasonable units, it's 10 to the 13 kilometers. So the closest star to us after the sun, no one get too clever with me here, is about 4 light years away. The distance to the center of the Milky Way is about 26,000 light years away. So you've got this huge jump going from just a few light years to many thousands. The actual diameter of the Milky Way is about 100,000 light years. The distance to the closest galaxy away from the Milky Way is 2.5 million light years away. And then the furthest object that we've ever observed, which was done by the James Webb Space Telescope last year, distances, the definition of it gets a little bit funny when you get to these large distances and weird cosmology stuff, but the light travel time, the amount of time that it takes for light to travel from that object to us is about 13, was it billion? Billion, 430 million light years away. So we've got these really big distances. But we're just going to stay in this little region here, so in a region of about 1 to tens of thousands of light years. So this is what Orion actually looks like when we peer outside of our galaxy just a little bit. So the brightest star, Betelgeuse, it's a super red giant star that could go supernova at any moment. We just don't know when. It could be tomorrow, it could be hundreds of thousands of years away, but it's pretty close to the end of its life. That is about 640 light years away. The Orion Nebula, which is actually the furthest object within the Orion constellation that makes this Orion shape, that is about 1,300 light years away, and then all these different stars that also make up Orion are at all these different distances in between, so going from about 700, 800, 900, and 1,000 light years away. And when we try and look at Orion at different perspectives, this is what it would actually look like if we were in a different part of the galaxy. It does not look like Orion at all anymore. Once you start just turning your perspective, we only see Orion as we know Orion from the Earth, because that's just where we are in the Milky Way. So there are a lot of different animations of this, which I think are really cool, of these different constellations, but all the constellation are just these different stars that just happen to line up in our line of sight to create these groupings that we then perceive as images. And then we apply stories to them, which I think is a really cool and unique part of our humanity. So here's a diagram of the Milky Way. I'll show you where all of these constellations are within this Milky Way now, but we're right here in the middle. You can see that little red dot right here. The center of the Milky Way is over here, so there's a super giant black hole right here. Very crowded region of stars over here, and then we've got all these spirals coming out. We can't really see anything down here at the top of this diagram because all the dust and the stars in this central bar are hiding everything, but we can see everything that is pretty much around here. At least optically we can see them. And this is where all of those constellations are within the Milky Way. It's actually a really small region. It's just within this circle here of about 5,000 light years in radius. So all those stars are actually pretty close to us when you compare it to the rest of the Milky Way. This label here says this is the naked eye limit. What they're trying to say is this is pretty much like the furthest star that you can observe as a single star using just the naked eye in pristine conditions. Not the best wording. You can actually see much further. For example, in great skies, you could see the Milky Way bar, and you can see the Andromeda galaxy. But all this is trying to say is, yeah, all the stars that make up all the constellations that we know are actually just within this circle. So this little plus here is the Orion Nebula, which is 1.3 thousand light years away. Pleiades over here. Everything is actually really, really close to us. So these are the 88, quote-unquote, official IAU constellations. When there's a discovery of some object in space, they'll usually be classified with some number and also which constellation it can be found in. So the constellations, I should have actually put in the lines here of that delineate between different constellations. But say if we find an object over here, we'll say that it's in Ursa Major, and it has this such and such number. So for example, the black hole that's in the center of our galaxy, we call it Sagittarius A star because it's in the constellation of Sagittarius. One of the brightest X-ray galaxies that we know of is called Cygnus X1 because it's in the constellation of Cygnus. So the question is, how do we come up, or how did we decide these are the 88 constellations that we are going to use as astronomers? So we're going to go into the history of those 88. So it all starts in Mesopotamia, which today we know as Iraq and parts of Syria, where the Babylonians and the Sumerians lived. And they recorded astronomical phenomena and did a lot of mathematical computations on stones and clay writing tablets, like this one over here, which of course is in the British Museum, as with everything. And yeah, they started grouping up the stars because they realized that everything was quite kind of periodic. So could they start to predict when these stars were coming around again? These constellations were defined approximately like in the years 1300 to 1000 BCE. And these constellations were all related to the ancient Mesopotamian religions, which I don't really know about, so I can't go into much. But the first evidence that of the zodiac constellations, so everyone knows like Sagittarius and Aquarius and all of them, was approximately around 600 BCE. We'll come back to them later on. So the ancient Greeks then adopt these Babylonian constellations about 400 BCE and revise some of them with their own myths and legends and gods. So, for example, the great poet Homer in his Iliad and Odyssey started talking about some of these constellations that we even know today, such as, I think it's pronounced Boots, but I'm not entirely sure, Ursa Major, Orion, and the Pleiades, or we also sometimes call them the Seven Sisters. So this knowledge came from this area of the world up to ancient Greece over here. And then the Ptolemaic kingdom, which was an ancient Greek kingdom in Egypt, they took on these Greek and Babylonian constellations and mixed them up with their own gods and stories as well. This is where we first see anthropomorphic figures being attached to these constellations. So for example, there's an Egyptian star chart over here with, I should have made this bigger, but yeah, there's some small anthropomorphic figures attached to recordings of the stars. And the oldest depiction of the modern zodiac that we have is called the Zodiac of Dendera, which was found in the Dendera. It's not a tomb, I forget what exactly it was, but I think it was like a place of worship back in those times. And this is a reconstruction of what it looked like. It was very colorful and very beautiful. This is what it looks like today. It was actually found in the 1800s, and it was taken to the Louvre. So this is proof that not all stolen artifacts go to the British Museum. And then 150 Common Era, Ptolemy's Almagest was published. Ptolemy was a Greek mathematician, astronomer, has nothing to do with the Ptolemaic kingdom. That completely confused me for the past couple of days. Turns out completely different. He recorded the geocentric model, which is the idea that the Earth is at the center of the universe. Surprise, surprise, it's not. But that was the standard belief for the next millennium and a half. He also defined 48 constellations, and this book was the standard for astronomy in medieval Europe and for the Islamic kingdoms in the medieval period as well. So this is what was in the Almagest. So here's an Arabic translation of it from the medieval times. Here's, I think this is a Greek version of it. So this column here says what constellation it is, and it gives the positions and the brightness of the stars that make up these constellations. And then this is his geocentric model, just to show the Earth at the center, and then the Moon being the first to orbit around the Earth, and then Mercury, Venus, and then the Sun, and then Mars, and so on. So yeah, this was the standard. And then we got to the Renaissance, and people realized that geocentrism was actually wrong, and we slowly realized the Sun actually wasn't at the center of the universe, and Milky Way wasn't the center of the universe. There's actually nothing in the center of the universe. It doesn't make sense to define it. The Northern Hemisphere, though, is still based on those 48 constellations defined in the Almagest, so nearly 2,000 years ago now. But then the Europeans started to explore the Southern Hemisphere, and by this point, they had never been down to the Southern Hemisphere, so they started to record the stars down there and started creating their own constellations. And wow, they were not creative. So one of the proposed constellations down in the south was called Roba Carolinum, or Charles's Oak, by an astronomer called Edmund Halley, who gives the name to Halley's Comet. So in this figure here, we've got this boat, which is Argo Navis, which is one of the constellations defined in the Almagest. He stuffs in this little oak tree down here to try and please the English king, just to be like, thank you for giving me money to do this work, please give me some more, and I will try and put you up in the stars like all the other gods. Sorry, I overheard that. Yeah, this constellation did not last very long, so yeah, he ended up not being in the stars forever. But yeah, this was pretty much what was happening over the next, 2 or 3 centuries. Different astronomers just inventing all kinds of different constellations in the southern hemisphere and competing with each other, and it was a complete mess. And it was a problem because we were making all kinds of new discoveries in astronomy as we were improving telescopes and observational techniques. So if we wanted to label this, say, nebula that we found as this constellation and some number, then you need to have some form of standardized naming convention for the constellations. What we needed was a consistent map that everyone agreed on. So this is one of those proposed maps. And yeah, this was made in 1750 by an astronomer called Lecaille. And then, as you can see, he created all kinds of weird stuff. So some of them kind of make sense, like maybe there's a dove down here, there's a chameleon, which you would find in the southern hemisphere, but then also he decides to put in there's a telescope in here somewhere, an octant, there's a lot of lab supplies. So you can tell, like, he was really, like, it's really crazy about how amazing 1750s technology was progressing. So I found this quote, which I found was really funny. About the latter half of the 19th century, star charts analysis featured loosely fabricated patchworks of constellations with arbitrary boundaries and varying shapes and sizes. Many included elaborate drawings of figures overlaying the stars. That's like the most important thing here. You want to know which stars you're looking at, but yeah, they just let their artistic prowess just go over what was in the sky there. And different sources gave different delineations. So it was growing complexity in astronomy, but we needed more accuracy, and it necessitated the refinement of such vague impressions of our sky. So this was written in Astronomy magazine last year, but the quote that I particularly like, which I showed up here, it looks like someone's attic. Telescope, octant, you know, all kinds of lab supplies. Yeah, not wrong there. So I did a little more Googling over the past few days, and I came across a website which I just couldn't stop laughing at this for a few days. They were trying to show, like, yeah, pretty much anyone can create their own constellations. It's pretty much like a dot to dot, right? So what they did was they took the constellations of Perseus and Andromeda, and they just gave a outline of just the stars and asked their readers to do a dot to dot and invent whatever constellation that they want. This is what they came up with. We got a gecko, we got a jumbo jet, we got a hammerhead, and my personal favorite is Mussus Major. I would much prefer Perseus to be labeled as Mussus Major. I think it's far more appropriate. And it looks like a moose. Like, if you look at these stars and you just connect them all together, yeah. So, back in 1920s, 1930s, the International Astronomical Union finally came up with a standardized constellation map. And this is the outlines of all those constellations today. So in the northern hemisphere, you'll probably recognize quite a few of them. So for example, you've got the zodiac constellations following the ecliptic here. The ecliptic is the line that the sun follows throughout the year, which is why the zodiac is here, because that's how the zodiac is defined, but I'll go into that a little bit later on. Where is Orion? I forget where Orion is. Right here, there it is. Yeah, and you've got Cassiopeia, and then you've got Ursa Major and Ursa Minor, and all those that we know very well. Down at the bottom, there's constellations that we don't really know so well, because we live in the northern hemisphere, and yeah, we can't actually see them from up here, or the majority of them anyway. I've not seen Carina, I've not seen Octans, I've not seen Mensa. I don't even know what half of them are, to be honest with you. But they're probably just some things in someone's attic. But all these different colors show like different years they were quote unquote created, discovered. So gray being all of those ancient constellations that were defined in the Almagest, and then different astronomers creating these different constellations in later years given by the different colors. So we're going to play Guess the Constellation just for a little bit of fun. Just to see how well your knowledge is and to just give me a chance to have a glass of water. I will give you a clue if no one can actually get this one, just by showing what the outline actually is. So does anyone know what this one is? Cassiopeia. Yeah. I just really wanted a drink of water there. I got it so quickly. So yeah, this is Cassiopeia. Easily found as being a giant W in the sky. It's my favorite because my name's William. It's quite easy. So Cassiopeia was a Greek goddess who was very vain. So in this zodiac depiction here, she's shown holding a mirror, looking at herself. In other depictions, she's actually tied up to a chair. Yeah, you'll find out pretty soon that they really like to put all the male heroes in the sky, and then all the women just get treated terribly. So this is the next one. I'll get rid of my little laser pointer so it not confuse you. What constellation is this? Here's a little bit of a trick question. Okay, so here's the outline for it. Anyone want to give a guess? Not Taurus. Pegasus? Half correct. It's actually Pegasus and Andromeda, because they share the same star over here. So the reason they're not cheating is because this star here is actually a double star, so you can actually just like borrow one and the other from the two constellations. But yeah, the fact that that is actually a thing kind of does annoy me, to be honest with you. So Andromeda was the daughter of Cassiopeia, because Cassiopeia was vain. She angered one of the gods, I think it was Poseidon, and to appease him, they tied her to a rock, because why not? That's how things work. And then she gets saved by Pegasus, who... Was it Pegasus? I think. Pegasus is defined as a horse here. Perseus, thank you. Yeah, they start with P, I mix up. Thank you. Okay, gets a little bit harder now because it's already not hard enough. What constellation is this one? So it's given by this region here, defined by the red lines. This is in the southern sky. Okay, I'm going to give you a hint. This is what it looks like. It's this L right here. Anyone? Obviously, it's a clock. It's horologium. Oh, it gets worse, trust me. Here we go. This is the last one. Defined by this area here. This is all it is. It's actually kind of obvious. It's a microscope. No, it really, yeah. It's like, it points out in this direction, but you got the microscope going in this direction. I really don't understand. It's very strange. So what I was trying to show here a little bit is that these European travelers were kind of just like making it up as they go along. But what about other cultures? Because people lived down in the southern hemisphere at this time, but they did not consult these astronomers that were down there. They did not want to include their legends or their mythology. So I thought I'd just have a little moment to chat about that. I really don't know much about these constellations that they had, such as in Chinese astronomy or in Native American or indigenous Australian astronomy. So I'm not going to really talk about them much because I don't want to talk on their behalf. But why would different cultures have different constellations? So there are a lot of different reasons. It's because the main one is that everyone lives on different latitudes. If you live on different latitudes, so like how north or how south you are, you're going to see different groups of stars at different times of the year. And that's going to inform your knowledge of the stars, or knowledge of space kind of a bit differently. Every different community will have different origin stories as well. They'll have different ways of thinking. They'll have different landscapes that they can connect the stars to, different climates as well, and different agricultural techniques, which I'll show in Celtic astronomy later on, which is kind of, the stars were really important when it came to agriculture. And I just want to highlight that it's really important to preserve and celebrate these different cultures because they all have a connection to the stars, they all have their own unique stories, and I think it's really important just to keep that culture alive, just to know how people connected to their ancestors, to their elders, to their land, and to their identities. And it's just also important, human history, they shared lessons through these stories and through the constellations as well, and had different knowledge of the skies as well. So I didn't want to talk on behalf of these different groups, but I do have some recommendations for resources if anyone wants to look into them further. I have not actually read this book yet, but I've been recommended it a lot. It's called The First Astronomers, How Indigenous Elders Read the Stars. This is written in, about the Aboriginal Australians by a researcher called Dwayne Hamaka with some of the elders and knowledge holders in Australia. We also wrote a review about this within Astrobytes. Check it out. Dr. Kirsten Banks is one of my favorite science communicators. She's from the Wiradjuri tribe in Australia, and she talks about how her group of people connected to the planets and to the stars over, the 60,000 years that Aboriginal Australians have had a community. In the US, there's a collective called Astrodigenous. They were, I don't know if they still exist. I couldn't see if they were still active. I'm a little concerned because, what's going on in the US right now, they're probably considered to be quote unquote woke, whatever that means. So they've probably lost a lot of their funding. So that concerns me a lot. They were doing a lot of great work on preserving knowledge of indigenous astronomy in the US, or what they call the US and also the world as Turtle Island. And then I thought, could I find any information on what the ancestral and traditional groups in Nashville believed about the stars? And I couldn't actually find anything, which kind of upset me a lot. When they were driven from these lands, they were probably, a lot of that knowledge was probably lost. And I think that's a big loss for Nashville and for Tennessee as well, because just imagine what they knew or how they connected this land to the stars. I think it would be really important to know. But we're probably not going to know for quite a while, to be honest, because all that funding is now cut. So, just change speed a little bit now. How do we use the constellations? How can you use them today to do astronomy? So one of the coolest ways, or the most practical ways that I see using constellations is using the square of Pegasus. Because if you count the stars within the square, not counting the 4 stars that actually make the square, just the stars that are within it, is actually a good way to say how good, how good the quality of the dark sky is wherever you are. Or, another way to frame it is how bad is the light pollution there. So in Nashville, you definitely cannot see any stars within a square of Pegasus. It's going to be really poor. 3 to 7 stars is kind of average for the world. If you find 8 to 11 stars, it's going to be really good. You can do some really great astronomy. You can maybe see the Milky Way. More than 12 stars, though, I've never been to an area where I can see more than 12 stars in the square of Pegasus, and I really want to, because I can only imagine just like what the night sky is going to be like. The usual thing that people do with constellations today is, or specifically asterisms, is to star hop. The term is actually called star hopping, where you can use a set of stars to point yourself to another set of stars. So for example, the plough, what do you call it? The Big Dipper here? Yeah. In Welsh, we call it Jack I Wagon, which means Jack and his wagon. It's like a little wheelbarrow. So you can take the 2 further stars on the right, create just draw a line, and then it will point you to Polaris, or the Northern Star. And that's how you can find yourself to go north. You can also use your hands to try and figure out how many degrees between different objects in the night sky. And you can do this a little more accurately with an octant by comparing different stars to each other to find where you are in terms of latitude, and that's how you would navigate the sea. Before GPS, anyway. Oh, what am I doing on time? I forgot to put my stopwatch on. Okay, so I'm going to quickly go through how these constellations are changing, though, because they actually do change over time. You wouldn't believe it. So the Earth is actually wobbling a little bit. The specific term is it precesses. This is just a normal part of just having, it's a normal natural thing of spinning tops when there's like absolutely no resistance. So for example, here's a gyroscope, it's spinning around its rotational axis, but as it's rotating, that it also just wobbles. And this is actually a really stable, normal thing, so you do not have to worry. So the Earth also precesses. The axis of rotation is rotating around with a period of about 25,700 years. So you do not notice it at all. But what happens is that the North Star actually changes over time. So this is the line that the rotational axis of the Earth will just like draw into the night sky. As you can see at the year 0, or year 1 CE, I guess, Polaris was actually the northern star. It was true north for us. But over time, the Earth's axis will rotate away from Polaris, and is actually not quite the northern star for us anymore. And over time, that's actually going to become more and more pronounced. So about like today, Polaris is just slightly off being true north. So if you were to just like point a camera up in the night sky and track the stars, you would actually see Polaris just doing this tiny little circle. So this has important implications for the zodiac. So the zodiac is defined as your star sign is whatever or wherever the sun is traveling through at the time of your birth. So, for example, I'm apparently Aquarius. So the constellation, the sun was in the middle of the constellation of Aquarius at the time of my birth. And then over time, like the Earth will then orbit around the sun. So in July is it Leo, supposedly, I think. The sun is in the sign of Leo. I'm going to say supposedly, though, because you'll see why that's actually not quite true. It was true 2,000 years ago, but it's actually not true now. So the Earth precesses. So that means over time, the the sun is in a different star sign going over all these different years out of a particular month. So for example, 2,000 years ago, my star sign is Aquarius. The sun was in the constellation of Aquarius between January 20th and February 18th. That's actually not true anymore. Today, Aquarius should be defined as being February 13th up until March 14th. That doesn't change my star sign, funnily enough, but for other people it actually would. And this is because just the Earth is wobbling. So this is showing, is this actually going to work? Oh, that's unfortunate. Here we go. So this is showing where the sun is in the night sky and the month of September over these 26,000 years of the Earth's processes. And as you can see, in September, the sun is in these different stars in the zodiac over time. So as time goes on, we do not want to see blue, thank you. The zodiac dates will actually change. And that's just because the Earth is actually precessing. So that is one way that the constellations kind of change over time for the Earth. Next thing I have, though, is also something called proper motion. So we're a star in a giant galaxy, and all of those galaxies are orbiting around the center of the galaxy, which is a supermassive black hole. The closer you are to the center of that galaxy, the stronger the gravity, so in order to not fall towards the center, you have to be orbiting much, much faster. When you start going towards the outer edges of the galaxy, though, you can't travel so fast as those inner objects. You have to go much slower, otherwise you just get slingshotted out of the galaxy. So those outer objects in the galaxy orbit a little bit slower. So you get this nice, pretty spiral pattern where those inner objects are orbiting really, really quickly, and then those outer objects orbiting much slower. It's kind of like, well, it's pretty much exactly like our solar system. You got the inner planets orbiting the sun in a matter of days, for us a year, while those outer planets are orbiting much slower and taking years and years to orbit the sun. So that means, for example, let's say our sun is this green one, this green little object over here. That means the stars inside to it is actually going to be moving much faster compared to our sun, and then the stars that are outside of it are going to be orbiting much, much slower. And this apparent change we call proper motion. I don't know why it's called proper. It's a little bit of a strange nomenclature again, but here we go. So over time, the stars will actually change position within our galaxy and within our night sky. And this is how the Big Dipper will change over time. So we're starting at about 100,000 BC, and then we're going to 100,000 AD. Yeah, it changes quite dramatically. It doesn't even look like the Big Dipper at some point. And you can't use those two end stars again to try and point towards Polaris, because these two stars change position, and then Polaris will also change position as well. Here is a video from the European Space Agency using actual measurements from its satellite called Dyer, which was shut down at the beginning of the year, recording all the stars that it was trying to observe, showing its proper motions over time, showing where they're going to be. I think it's like 100,000 years into the future. This is just like a speeded up version going backwards and forwards and showing how the Orion constellation changes over time. So some of the stars in Orion don't appear to change a lot. Betelgeuse really moves far though. And this cluster of stars starts popping in as well. I think it's the Pleiades, but I'm not entirely sure. I tried looking into that. But as you can see, these stars are just like moving all over the place, and they move really, really quickly. You know, quickly, I mean like over time frames of like hundreds of thousands of years. Here's a video showing how all the stars within the Milky Way, or 40,000 stars in the Gaia data set, travel throughout the Milky Way over 1.6 million years. So the length of the tracks show 80,000 years of that travel. Here's a really pretty pattern, I think, but it's just showing that these stars are actually moving quite a lot compared to the Earth. And the Earth is also, and compared to the Sun, and the Sun is also moving as well, so this is just like the relative motion between all of these different stars. I would like to change slide, please. So all I want to say about that is that we live in a unique time. These constellations are changing. The stories that we have for these constellations are just unique for us right now. And thousands upon thousands of years into the future, they're going to change because these constellations are going to change. So yeah, we live in just a very unique standpoint in the universe's history, not just human history. I think it's kind of incredible that we just have these stories for all these different constellations. All these different cultures have different stories for them as well, and I think it's just a very human thing, which is just very beautiful. So yeah, the final example I have of this, related to Nashville, the astronomer E.E. Bernard, who gives his name to the Bernard Seifer Astronomy Society, which is our local astronomy club, found this star called Bernard Star. It's about 6 light years away and is actually the 4th closest star to the Sun, and you can see over years that it's actually moving compared to all the background stars, and it has the highest known proper motion of any star that we observe. So I want to show you some little bit of fun. If anyone just needs like some time to procrastinate at some point, this is a really fun little application that you can download onto your laptop, also onto your phone. This is Stellarium. This shows all the different stars and also planets and where the sun is, and all the satellites as well. The satellites are a huge pain in this thing because there's so many Starlink ones now. But yeah, you can see where all these stars are at any point on the Earth at any different time. So for example, we're in Nashville right now. If I put on the atmosphere and the ground, yeah, we can't actually see Barnard's star right now because that's where the ground is right here. It's not above the horizon yet. But neither is the Milky Way. You can also see the Milky Way. But this is a great tool if you want to see what is above you right now. Also any time in the future or in the past too. So here I've got Barnard's star, which I'm tracking at the moment. And what we can do is speed up the universe and see how it moves compared to the background stars over time. So we're going at a rate of about a couple of years every second now. You can see that it's just like slowly moving compared to those background stars. We can just speed it up a little bit and then, yeah, it starts flying. What we can also see is how these all these different constellations change over time as well. So you can play with this for yourself. I found a really good star to play around with this earlier. Sirius within Canis Major. If we start to speed everything up, and we've got to go really fast here. So you can see how precession of the Earth changes everything over time, or change like how we observe all these different stars over time by this little rotation effect that is going on over here. But what you can also see just slightly are these different stars moving. So for example, Sirius is starting to get closer and closer to this star as we go a couple of thousand years into the future per second. As you can see, like the main body of Canis Major here is pretty much turned inside out. And then we can go a little bit faster and we can just see how crazy some of these constellations become. They just, yeah, they just go all over the place. These different lines have just become a mess. So yeah, if you want to see how these constellations change over time, either into the future or into the past, play with Stellarium. It's a lot of fun. We're back on that. So yeah, Stellarium is actually a free download onto pretty much any operating system that you want. If you want to learn about the different constellations and different groups or different societies over time as well, you can actually change which constellation groups that you can look at as well, and they'll have like a little bit of history and description for them all as well. It's a really cool piece of software. Okay, so now I'm going to talk about home. Okay, so first of all, who are the Celts? I thought I'd just go through a little bit of history on who the Celts are, how these Celtic nations became what they are today, and how these languages, how these languages started and where they are today as well. So the Celts were a group that were mainly in Europe for many hundreds of years, about 1,000 years BCE. And then over time, they slowly migrated towards the West, and they ended up in the UK, or what we call the UK today. And the Celtic nations, or quote-unquote the Celtic nations as we define them today, are these following regions. We got Alapa, or Scotland, Eire, or Ireland, Elanvanin, or the Isle of Man, my home, Cymru, Wales, which is this red region here. If anyone tells you they're from Wales, you'll know where they are from now. You got Cerno, or Cornwall, and then Breitz, or Brittany. Brittany in north western France actually has its own Celtic language, which I'll go into a little bit too. These are all the different flags, so Irish, Scottish, Cornish, Isle of Man. Wales has the coolest flag. I just need to say that. I just love it so much. This is the Britannic flag, and then this is also the Galician flag. There's maybe a connection between the Galician language and the Celtic languages too. It's not actually proven, but it's kind of an interesting history. Galicia being in northern Spain. So this is how the Celtic languages are connected to all the other languages within the Indo-European language group. So the Indo-Iranian and then the European languages split off pretty early on, and then the Celtic languages pretty much split soon straight after that. If you want to know, English is over here. It just has this long winding path going from Germanic and West Germanic, and then Anglo, what does that say? Frisian, I think, and then it became English and all the other derivatives of English, and all the other related languages like German, Dutch as well. But yeah, the Celtic languages are pretty much like its own branch that just broke off very early on. It's why it's this very unique language itself. So the state of the Celtic languages today, we got Scottish Gaelic or Gaelic that's still spoken quite a lot in the Western Isles of Scotland. It's about 57,000 speakers. Manx went extinct about 50 years ago, but it's had a revival, and there's still about 1,500 people learn how to speak Manx. We've got Gaeilge or Irish Gaelic, which is spoken by close to 100,000 speakers in Ireland, and they learn it in school now, which I think is really, really cool. They've brought it back, and they're mostly concentrated around Galway, and I think this is Dumfries, and also County Kerry down here. Welsh has the most speakers out of all the Celtic languages. It's actually pretty strong. We're about 500 million speakers strong. I came from a village where about 90% of the population could speak Welsh. I think most of them were first language speakers too. But we're all bilingual. We're a bilingual society now. I come from a family which spoke both Welsh and English pretty much in equal measure. Cornish went extinct about 200 years ago, but there was a revival, and there's possibly about a couple of hundred people still speaking it. And then Breton in Brittany. In 1950, there were about 1 million speakers, and then the language collapsed, which are into reasons I'll go into a little bit later on. It's now about 200,000. I think maybe like a census last year said there could be close to actually 100,000 now. It's dropping really quickly. In Argentina, there's actually a colony of Welsh speakers there in a region called Olatva in Patagonia. There's about 5,000 people who could speak Welsh and Spanish, but they can't speak English, which is kind of cool. And then Scottish Gaelic or Gaelic is also spoken by about 2,000 speakers in Albanug or Nova Scotia, and then Eilean Eoin, I think it's pronounced, or Prince Edward Island. Prince Edward Island is where Anne of Green Gables is based. So these aren't Celtic languages, but I need to shout them out as well because they're also important to the history of languages within the UK, but Scots and Ulster Scots are their own separate languages as well, and they evolved at about the same time as English. They come from the same branch, but their own separate languages. Scots is spoken by about 1.5 million speakers in Scotland, and mostly concentrated to the northeast. And then Ulster Scots in Northern Ireland, where there's about 25,000 speakers, mostly in the north of Northern Ireland. So I wanted to show what the language diversity of the UK is, especially this week, because our dearest Prime Minister decided to come out and say that everyone must speak English in the UK, because we risk becoming an island of strangers if we don't. About 50 years ago, most people in the UK couldn't actually speak English. They all spoke these different languages. So this kind of comment really just made me so annoyed. And the reason for that is because the name Wales was actually given to us by the English, and it actually means a Romanized stranger. It means that I've been a stranger in my own country, or the Welsh people have been strangers in our own country for 1,000 years. To give you the opposite perspective, we see ourselves as compatriots to each other, or comparogi, which is where the word Cymru, which is Welsh for Wales, actually comes from. It means that we're all friends with each other, and yeah, it's a complete opposite to what the English think of us, or what they thought of us, and some of them still think of us today as well. So to just give you a very short history of the UK and how these Celtic regions and languages evolved over time. First evidence of people within what we call the UK today was about 900,000 years ago, where the Neanderthals first moved over there. Celts didn't arrive until about 1000 BCE though. Then Roman invasion happened at about 43 CE, and it pretty much separated the Celtic nations into three distinct regions. So you got the Picts up here. The Picts died away, but they had their own Celtic language for a long time. But then over about 1,000 years, they slowly changed to speaking Scots. You got the Gaels here that speak today Scottish Gaelic and Irish Gaelic. And then the Britons over here who spoke this old Brythonic language, which later became Welsh and Cornish. Where was I going with this? And then end of Roman rule was in about the 5th century. The Romans only made it up to this top of this red line, so this is where this whole idea of these Romanized Celts down here and then the non-Romanized Celts up in the north. The Britons were led by various different kings and different kingdoms. The main one was the Brenin Arthur, or King Arthur. So if anyone asks you where Arthur came from, he did not come from England, he came from Britain. He was the king of the Celtic groups. And then the Anglo-Saxon invasion and settlement happened between the 5th and 11th centuries. They slowly pushed all the Brythonic people and Celtic people towards the west into what we call Cornwall, Wales, and Scotland and Ireland today. So for a long time, this region actually spoke an old form of Welsh. It was a region called Yr Hen Ogledd, which means the Old North. So there's actually a lot of old Celtic names in that region today, which is kind of cool. This is a hill fort. It's actually just outside of my village. The Celts were quite well known for making their hill forts to try and protect themselves from the Romans, and these are like the little huts that they lived in within those hill forts. To give you, so I know my history better than pretty much all the other nations, so I'm just going to give you a little more perspective on what Welsh history is like, and because not a lot of people know about Wales, I just wanted to I had a chance to give you a little history talk, so why not? So Cymru at the time was a patchwork of different kingdoms led by different kings, but they all followed the same rule of law that was defined by the king Hywel Dda, or Good Hywel. And that's how we got our identity as being like this one patchwork of kingdoms, because we all followed the same laws. Over time, we then defined a Tywysog of Cymru, or a Prince of Wales, who is a ruler of all of Cymru. So we had one king that was pretty much the leader of all the other kingdoms. And yeah, that's how the term Prince of Wales started. Our last, for lack of a better term, true blood Prince of Wales was Llywelyn and Llywelyn, who was killed in a battle by the English in 1282, and this led to the annexation of Wales into England. And this Prince of Wales title was then given to the heir of the English throne. And it was never again to be given to a Welsh person. So when you hear about Prince of Wales in terms of like William and Charles, that is why. So we decided to rebel. There was a lot of rebellions. There was a bunch of leaders within the Welsh people who took the Tywysog Cymru moniker for themselves, and they actually took over parts of Wales back from the English for a long time. But unfortunately, that didn't last very long. But this is why we have a lot of castles in Wales, because the English needed to protect themselves and also needed a way to quell the rebellions. And we ended up bankrupting them quite a few times, which is quite funny, I think. But then we ended up becoming a part of the Union of the UK, the Act of Union back in the 16th century. And then those rebellions ended up turning into industry. We were the biggest exporters of slate and coal for many, many centuries towards the end of the second millennium. So this is the quarry mine that is very close to my home, is about 5 miles away on the mountains of Gwlad. This is actually the second biggest quarry. The largest one is just on the other side of the mountain. So that's how big the industry was. Should have made us rich. It didn't, because all that money was taken out of Wales and sent to England. But the biggest thing that affected us was a event that we call Brad Llyfrgleision, or the treachery of the Blue Books. It was a report that was written by some ministers that were paid by the British government to go into Wales, to go to the churches and to the schools and see how the Welsh language was, how it existed and how it made the Welsh people behave. And they came to the conclusion that the language was a barrier to the moral progress and commercial prosperity of the people, and it's not easy to overestimate its evil effects. So in order to try and solve that, they started to suppress the language. One way they did that was they forced the children to wear this block here called a Welsh knot. So if you were caught speaking Welsh in school, you would have to wear this really heavy block on you. But there was only one to go around. So the idea was that you would then, if you hear someone else speaking Welsh, you would then have to give the block to them, and it was to try and get these kids to start telling on each other whenever they spoke their native language. And then whoever wore it at the end of the day would then get beaten by the teacher. And another way that it was also, the language was also suppressed was people were kept in poverty by taking all this money out. This was very similar pretty much across all the Celtic nations. We had the clearances in Scotland where the soldiers from the British Army would go into Scotland and set fire to people's houses and separate families. And I would like to say this doesn't happen here anymore, or anywhere in the world anymore, but unfortunately, yeah, it still happens. The equivalent of the Welsh knot, the tally stick in Irish, and there was also the symbol in Brittany. They also happened in those regions. The teachers in Brittany were told to destroy or to kill the Breton language. We had the Dress Act back in 1740s, which stripped the Highlanders of their tartan dress, which is kind of wild, right? Because everyone knows like plaid and tartan is like the main Scottish thing now, but for a while it was actually banned. Language bans as well, famines, which could have been prevented by the British government, but they did not. And this led to a lot of emigration. And this is how a lot of Irish and Scottish settlers arrived here in the US, because there was just such amount of poverty and destruction going on. So back in the 20th century, a revival started. We did what we do best, which is rebel. So the Irish people rebelled first, and they created the Irish Republic. Back in Wales, we fought back for our language rights, and over time, we were able to get our own TV channel and radio stations and start teaching Welsh in schools again. This was a funny moment in Welsh history, which I found just great. We took down all the traffic signs that were in English only. The only ones that were allowed to stay up had to be bilingual or only Welsh. And that's why we have a lot of bilingual signage across the UK, across Wales and Scotland and Ireland now. In Brittany, even though that French is the quote-unquote official language, they set up a bunch of immersive schools teaching Breton. In Ireland, they started a load of Irish Celtic games again. So this is the game of Carnegie over here. And then at the end of the 20th century, we had devolution. So the Scottish and Welsh governments were set up, and we have some of our own laws to decide our own healthcare and decide on our own education systems now too. So culture today is actually really strong. So this is the Eisteddfod here, which is a big part of Welsh language culture. Particularly, this is the Gorsedd o Beirdd. So this is where all the druids come together to announce the beginning of the Steddfod, which is a big Welsh language festival where people compete in all the different arts. This archdruid here will then, towards the end of the Steddfod, chair the best poet for that year, poet in a very specific form of Welsh prose called Cynghanedd. Welsh TV, just a couple of months ago, we had a first series of Y Llais. Does anyone recognize what that is actually? The voice? Yeah. So a Welsh reggae artist won. And yeah, Welsh reggae is actually becoming a really big thing now, which is pretty cool. Irish language films are becoming big things. Some of them were nominated for an Oscar last year. This is the French nomination for the Eurovision 3 years ago. They actually sang in Breton for the first time. And then Celtic Connections is a festival that I really want to go to. A lot of Nashvilleian artists go to actually too. It's an international music festival which celebrates Celtic music and its connections to other genres of music from across the world. But there's still some issues as well. There's still things that we're rebelling and still things that we're fighting for. So bottom left, quite a lot of Welsh people actually want to become independent from the UK. There was a poll that came out last week that said like about 70% of 18 to 25-year-olds wanted to become independent, which is amazing. It was like the first time that's ever happened. The Gaelic language is always having a report every year saying without efforts to revitalize it, it's going to die in the next 10 years. And that's actually kind of true, because a lot of people are buying second homes in the Western Isles and removing homes from the local people, and they're being forced to emigrate away. France said that those immersive schools that they were teaching is actually illegal, and there were people trying to close them for a while. And then in Ireland, or specifically in Northern Ireland, the Irish language is still not an official language. So they're actually fighting for that at the moment. So here's some famous speakers of all of these Celtic languages. People usually ask me like who speak all these different Celtic languages that they might know of. Richard Burton spoke Cymraeg or Welsh. Matthew Rhys was a Hollywood actor, as well as Cerys Matthews, who's a musician. She lived in Nashville for about 10 years. Julie Fowlish is a singer. You might know her as the musician in the soundtrack for Brave. Thank you. And then you had Cillian Murphy, who speaks Gaelic or Irish. And then, does anyone recognize who she is? Mari Anna Niclodge. So she moved to America in about the 1930s and married a guy called Fred Trump. And now her son is one of the most richest and most powerful men on the planet right now. Okay, so I'll finally go into Celtic Constellations. Thanks for hanging on to me through all of that. So, the Celtic people, very agricultural, and we needed to know when the seasons were changing. Specifically, when to move all the different animals from different farming regions or different pieces of land between the summer and the winter. And also, like, we live pretty far north, so we've got long summer days and long winter long days in summer and also long winter nights that are just very dark. So this is the Celtic calendar here. I won't go into too much detail about it, but it's split by these different festivals and also the equinoxes and the solstices. So the first constellation I'll talk about is Mapon or Orion. Most of these I'm going to be talking about is actually going to be Welsh because I know them better. But Mapon is a hero from a piece of mythology called Cilch ac Olwen. He was one of King Arthur's soldiers, and he was the strongest one, or the only one who could handle the dog Dritwyn, who is represented by Canis Major here. Canis Major being having the star Sirius, which everyone knows as the dog star, so connection to dog here. And the story is pretty much all about how they try and find this big monster boar called the Turchtruith. And yeah, that's pretty much all the story is. It's very long, but it's a very fun adventure. I recommend looking it up. But yeah, Mapon represents when the harvest begins, and when the winter months start coming in, because the Turchtruith is after which they found them. They had a big feast, and that's when you have the big feast months. Today, this is actually a pagan holiday called Mapon. Then we've got Perseus and Andromeda, or in Welsh we call them Lleuchaw Gyffes and Blodeuwedd. So this comes from a piece of mythology that we call the Mabinogi, specifically the fourth branch. And this is a little while, so please hold on. Blodeuwedd was created by the Dewin, or the wizard Gwydion, for the soldier Lleu, who is also one of King Arthur's round circle. But she didn't want to marry him. So she conspires to kill him along with her, conspired to kill Lleu with her lover. During the attempt, though, Lleu turns into an eagle, because of course he does. Gwydion then finds Lleu and returns him to human form, and they bring him back to health in order to try and kill Blodeuwedd and her lover. Well, they killed the lover, but they end up turning Blodeuwedd into an owl, because why not? So this represents the winter constellations, though, i.e. the death of the sun god being Lleu. So this is when the nights start getting longer, and everything starts getting really, really dark, and this is when you should start hibernating. In Irish, the sun god is actually called Lugh. I don't really know much about him, but he's actually quite famous within Irish mythology. And this is my favorite one, so Caer Gwydion, or Milky Way. So when Gwydion, the wizard, tries to find Lleu when he's an eagle, he finds him in Kila, which is the constellation of the eagle. While he's looking for him, he leaves a trail of stars, which is now the Milky Way. My favorite version of this, though, is the story of Sgrieb Clown Uisnech, which is Scottish Gaelic mythology, or the track of the children of Uisnech. Uisnech was the king, and his sons went to battle, and the goddess Deirdre was in love with one of these sons. Well, the sons were killed in battle, and during their funeral, Deirdre then jumps in to reunite with her lover. The king was very angry about this, so he tries to separate them. So he raises them from the graves and puts them into separate graves. But two trees start to grow and intertwine with each other to connect the lovers together. This annoyed the king, so he tries it again, spreads out the lovers a little more, but the tree grows back, entwines a little bit more. So he decides to separate them by a loch, or lake. And of course, the trees can't grow over the lake. So what happens instead is a trail of stars forms to entwine the lovers forever, and that's how they get the Milky Way. This is a story that is mostly connected to the Gales in Nova Scotia. So I can't find any evidence for this, but I think this is because like these people have been separated from their homeland. So this is how they connect back to their home. The Milky Way sends them back home. So Celtic astronomical culture today, there's a lot of neo-paganism, so people going to these old burial mounds. This is my closest one called Bryn Cellidir, where they have a big summer solstice celebration with local druids. I haven't actually been to this yet, but we plan to at some point. We have a horse skull that goes around asking for treats and money called the Vadi Lloyd during some of these festivals, which is like the most ridiculous thing, but is also just a lot of fun. And then up in Scotland, they celebrate the Beltane Fire Festival to bring in the summer. I'm not entirely sure what's going on in this photo. I don't know what the blue people are about, but still, it looks really cool and a lot of fun. But probably the main thing that connects us to the night sky today is that we live in very rural areas. This is why the language still exists, because it's not really connected to big metropolitan areas. And that means that the skies are very, very dark. And they recognize the different sites within these Celtic kingdoms or Celtic lands today that are considered dark sky international preserves. So here's some areas. You've got this area in Ireland, which is great to see the Milky Way, down in Canterbury. Isle of Coll in the Western Isles, where you can see the aurora really well. And then you got Anisenki, which is a little island that you can stay for a couple of days just to take a look at the stars. So yeah, diolch yn fawr. Thank you very much for listening. I think I went a little bit over, so I apologize about that. But yeah, thank you for listening. Any questions?
All right, thank you, William. A wonderful history lesson and astronomy lesson. We don't get that. So, we're going to do a little Q&A now. We've got some microphones we're going to pass around so that everybody can hear and everybody at home can hear as well. So any questions we want to start off with? Oh, we got one in the back here. Hold on.
You didn't talk about henges. Do those predate the Celts?
Yeah,
And
they do predate the Celts, yeah.
And do you know if they participated in those after the fact at all?
Ooh, that's a good question. I'm not entirely sure, to be honest with you. They might have. So our version of a henge was this one over here in Wales. This is a burial mound, and those henges were related to those burial mounds quite a bit. So there might have been some like festivals or celebrations. Actually, I'm not entirely sure. I'll have to look into that. It's a good question.
Other questions? Oh.
I don't know anything about astronomy, so I'm just throwing this out there. But in the projection of where all the stars are going, is there much discussion of them all crashing into each other in some way? It seemed like a ballet in the sky.
I'll get those up. So that's a very good question. No, they probably will not collide with each other because you have these huge distances, like light years distances from each other. But these, compared to the light years, stars are really, really small. They're just like these little point-like objects just dancing around. So they'll maybe a small handful of them will get into like some orbital dance with each other, become a double star, but it's very unlikely that they'll actually just like directly collide with each other. The probability is incredibly small. If they did though, that would be such a cool event. Like astronomers will be all over that.
Any other questions? You have one? Okay.
I also don't know a lot about astronomy. However, I'm very interested. And I kind of maybe missed it. I don't know if you said this, but like, are the stars actually like fully moving that distance, or is it our perception of it from our point of view? Or like, are they wobbling enough to like just move, like wiggle across the sky?
So it's a little bit of both. So they're orbiting around the Milky Way, just like we are. So I'll get that diagram back up. Here we go. Yeah, we're all just like dancing around the Milky Way, and then some of them are moving faster compared to us, and some of them are moving slower. So yeah, it's just a little bit of both. And also, like, we're wobbling too, so our perception of where everything is as well changes over time.
How do we kind of marry the fact that like Earth's magnetic poles are moving 37 miles every year with, you know, the way Earth's precession is? How do we, as, you know, being geocentric from our perspective of being able to view these things, how do we kind of use terrestrial navigation and celestial navigation? And because the north is not the north that it used to be, and it won't be. And so these stars not only are moving in action outside of us, but also our perception of north changes every year. How does that influence astronomy as a whole?
So the way it depends on how you define north. Essentially, there's two norths in effect. You got the magnetic North Pole, which is where those magnetic field lines, like, essentially just like come out of the Earth. But the other north that we have is the point where the Earth is actually rotating, and they're actually just slightly off center from each other. So the fact that the magnetic North Pole is moving doesn't really change it doesn't actually change our perception of where we are and what we observe over time. It's the wobble of the rotational axis of the Earth, which is a different North Pole. But yeah, good question.
All right, so William's going to hang around for a little while, but let's give him another round of applause for fantastic talk.
Thanks, everyone.
If you have not been up to see the big telescope, we're probably not going to be able to view, but at least go up there and check it out, especially if this is your first time here. We've also got in the front lobby an exhibit about the 100 nearest and 100 brightest stars, and William had shown in some of his talk this evening, like where those stars actually are with respect to us, and you can go out there and you can see that in 3D if you like. So, but thank you all for coming this evening. Kevin, are there any questions online on the chat there? Should be at the very bottom. Oh yeah, Levi Schultz said, thank you for an illuminating talk. Yeah. I think that's it. Okay. All right. Well, thank you all again for coming this evening. Hope to see you next month for our next Meet the Astronomer, and check out our website for details on upcoming events.